Hello, everybody, and thank you for joining today's Digital Water Expert Session, FDEP and Predictive Modeling, What You Need to Know. My name is Jay Nelson, and I am the Head of Marketing here at Trinnex. I'd like to welcome you all and start by covering a few key items. The first is, yes, the session is being recorded, and you'll get a copy sent to you following today's session. We're really glad that you're all here. We know not everybody can make it all the time, so yes, you will get a recording that outlines the presentation today. We also encourage you to submit your questions and poll responses to our panelists today. We at Trinnex love to understand where you in the audience all are in your digital water journey. And this is a big reason why we host these digital water expert sessions. We aim to build community through providing practical viewpoints, innovation tips, and also give you a chance to get your questions answered. So I'd like to request that all attendees submit your questions using the Q&A panel at the bottom of your screen. This will ask the questions directly to our speakers and just helps us stay organized so that we can see and track all of your questions coming in. We may not get to all of these questions live, but go ahead and ask away. This gives us a good opportunity to understand what your distinct questions might be, and we can always follow up personally. We do our best to respond to everybody live while we're all here, but some we may not get to all of them, so some we will just follow up directly to you and get your question answered. Okay, so let's get started. First, I'd like to introduce our speakers for today's event, Da Yu and Katie DeHeer. Welcome, Da. Welcome, Katie. Glad you're both here.
Thank you, Jay.
Yeah, Da is a professional engineer with 12 years of experience in the water and wastewater industry. At Trinnex, Da is a sales engineer and focuses on connecting the water and wastewater industry with technology. He does a great job of it, I will say. Da is passionate about data science and is learning about its applications in the water and wastewater industry. And prior to Trinnex, Da worked as a consultant engineer and had experience designing a 200 MGD pump station and leading various master planning projects. Da lives in Cincinnati, Ohio, and loves to cook with fire in his spare time. So maybe you can cook me something sometime, Da. But would love to try it out.
We'll smoke meat, yes.
Yeah, it sounds great. We're also joined today by Katie DeHeer, our analytics consultant and machine learning specialist. In that role, Katie leads the development of innovative solutions that leverage data and support agility and smart decision-making for infrastructure leaders. Her 13 years of analytics experience spans across multiple industries, and most recently, she's been focused on educating regulatory agencies about predictive modeling in the context of LCRR compliance. Katie's one of the best people to talk to about this. Absolutely love every conversation we have and always learn something new. So Katie's very committed to helping water utilities leverage this technology to maximize field resources and protect public health. So thank you for joining us today, Katie.
Thank you, Jay. Happy to be here.
Da and Katie are two of my favorite people to talk about predictive modeling in this context. So I'm absolutely thrilled that they are our presenters today. You can find both of them on LinkedIn if you're on that social media network, and follow them for more insights around predictive modeling. So now I'd like to introduce this group to Trinnex. If you hadn't heard of us before, perhaps you have, before handing it off to Da. Trinnex helps infrastructure leaders advance their digital journey through proven processes, software tools, and consulting partnership. Our team has really decades of water industry domain knowledge, data science expertise, and an unmatched commitment to technical software excellence. We deliver innovation that is backed by this experience. Our team consists of digital water industry leaders with a proven history of bringing products to the market that our clients love. And we've been in this industry long enough to be experts in the field. We're agile enough to pay direct attention to your needs. And we're ambitious enough to deliver the next generation of technology to help you in your day-to-day. Ultimately, this uniquely positions Trinnex to deliver software that's designed by water experts for water experts like yourselves who are all joining us today. We're also very proud to say that we have a great presence in Florida, which is a key topic for today's discussion. Trinnex is working with JEA, GRU, ECUA, West Palm Beach, Martin County, Miramar, and South Martin County. So while our mission is to help water experts succeed in achieving their goals, we're proud to say that we're making that a reality today in Florida. So thank you everybody for joining today. And with that, Da, I'll pass it over to you.
Thank you, Jay. Welcome to this webinar again. I'm really excited to share with you as Florida is close to my heart. I used to live in Orlando as I worked as an engineer. And as you know, FDEP just published their guidance that is really important for many utilities. So what will we touch today? So here on the screen, you see at least 7 questions we'll try to answer today. It covers what FDEP just approved, what predictive modeling is and how it can help you, and what really it all means for your LCRR and maybe even LCRI looking into the next 10 years or so. So as you look at these questions, find out what you really are interested in, you will get answers today. And if you don't, feel free, like Jay said, to put your question in the Q&A and we'll try to answer as many as possible. So first thing is, FDEP sent their guidance out and released the approval of predictive modeling. What exactly did it say? Well, first and really the most important thing is predictive modeling is an approved method for classifying material in your inventory. That practically means that you can use the model to classify unknowns as known and tackle them that way. That has huge implications that we'll talk about. It also has requirements. Utilities are not required to gain FDEP's approval prior to using predictive modeling, but the burden is on the utilities to submit an approach and show that you have achieved a good performance and avoid bias, minimize a few negative impacts of the model. All that said, you have to defend the results, right? So you can use it, defend the results. And that is huge good news for utilities. Now, so some of you might be wondering why it's a big deal. If you're thinking about that, well, in the shorter term, as LCRR mandates, utilities are required to submit annual notifications if you submit any unknowns or lead galvanized require replacement. Those annual notifications mean that your customers, if you have 10,000 unknowns, 10,000 customers of yours will get notifications saying that you don't know the material of their service line. Maybe it's lead. That they probably think about that in their head. It's a PR risk. You also have a lot of work to do whenever you turn a valve, let's say, near one of those unknown locations. If it's lead or galvanized, there's nothing you can do about it. You just have to observe the requirements. But the unknowns will inflate the number of disturbances. And then if you work around them, you're required to send flushing instructions and filters. I live in Cincinnati. I had filters sent to me by my utility. And there's a feeling of fear when I receive that because my drinking water is not safe, right? That's what it says. You can avoid that if you reduce the unknowns, avoid a lot of it, I should say. Looking in longer term, LCRI just came out, I think around Thanksgiving. Everybody had a good Thanksgiving, I suppose. It mandates the investigation of all unknowns in 7 years. It also will require a 10% replacement rate every year. Starting 2027, by the way, the rule is written right now, and that 10% counts the unknowns. That is a huge compliance burden for many utilities. Katie.
Yeah, so let's talk a little bit about what predictive modeling is. So it focuses on developing data-driven models that find patterns in data and use these patterns to make predictions. So we get asked a lot, well then, what is machine learning? I've also heard of that. Machine learning is a type of predictive modeling for which models learn from a training data set and then are validated with a testing data set. So it's just a distinction for a type of model that has that train test split and uses that technique. So applying this concept to lead and copper programs, the model is trained and tested on known field verified service line materials, along with other information like property attributes and demographic data. And then this information is used to make predictions about unknown services and guide targeted field verifications. And the findings from the verifications are then fed back into the model in an iterative process. So, next slide.
So Katie, in other words, it can basically allow utilities to dig some to avoid digging all unknowns.
That's the idea, correct.
Great.
Yep. And then, yeah, Florida's guidance references representative data, and we're so glad that it does, because that's so important. So in order to begin predictive modeling, you need to have a subset or sample, as statisticians would call it, as a sample of field verified information from your water system. They need to be statistically representative of your unknowns. So when you hear the term representative, it simply means your subset of field verification data needs to be accurately reflecting the characteristics of the rest of the unknowns in the water system. So selecting verification sites at random is one method that is likely to get you a representative data set. It's a simple method, but it's not guaranteed. So randomness does not guarantee representativeness. And this is especially true in large heterogeneous populations, such as public water systems. So sometimes statisticians will use a technique called stratified random sampling to generate a representative data set. And this just means breaking the larger heterogeneous population down into smaller homogeneous groups, and then sampling randomly from those groups in a way that's proportionate to the population. So that's a technique that we use, and it's always nice to have a visual. This example on the screen is a representative subset of field verifications recommended for one of our customers in the Southeast. And you can see that all unknowns are, on the map in the top screenshot, and then their representative field verification set is in that lower screenshot.
Thank you, Katie. I think in simple terms, it just means, right, for a utility who wants to do predictive modeling, you can't just get data from the west side and expect the model to predict what's happening on the east side. You just got to spread it out. Yeah.
Correct. Yeah.
Thank
Absolutely.
you for explaining that.
For sure.
Well, another question we get asked a lot, and Katie, I'm so glad that FDEP actually also wrote into their guidance, is the 95% confidence level. Well, what is that? Well, looking at this jar, I think we all want to take something out of it and eat it. Let's just talk about a common experience. If we just take out one and it's red, we might and without seeing the rest of the jar, we might think that this jar has red MMs. But that couldn't be more wrong, because we know there are many other colors if we look at all of it. So then the question is, how much of the jar do I need to take out so that I can observe what's in my hand and get a good idea that what color is in this jar? And the answer to that question is, well, some. And that's what 95% confidence level means. It's a statistical sort of benchmark to say you've taken out enough MMs from the jar so that when you look at your hand and conclude what is in this jar, your observation from what's in your hand is generalizable to the rest of the jar that you did not take out. So to achieve this, you just have to make sure you take out enough MMs. Now flip it to the predictive modeling case. Like Katie said earlier, it's digging some to avoid digging all. So how many you need to dig? Well, that is determined in one part by this confidence level. You just got to make sure you dig enough so that what you have found from the field is representing and generalizable to the rest of your unknowns. Another concept that FDEP also wrote into the rule is the 90% accuracy. And I know this is going to be very confusing because the 95% confidence seems to have covered it. So let's take another example. If you like sweets, please just enjoy this this analogy. So on the right-hand side, now we have different colored MMs, red and white. So let's call the red ones lead, the white ones non-lead. You see, our task is not to know how many red and whites are in the jar, even though we can take a handful from the jar and get an estimate. Our task as utilities task is to know where the red ones are and label them that way. So this concept of accuracy is not about whether we have done enough to know that our hand represents the jar. It is to know whether when we ask the question, what color is the on the bottom right corner of the jar? And when we say it's red, we are correct. How many times? 9 out of 10 times. That is 90% accuracy. So essentially, it's a different matrix. It requires more sample or more MMs from the jar for the model to know where the lead or non-lead service lines are. And to really take it a step further, if you look at the graph on the left-hand side, we have two y-axes. The y-axis on the left shows the number of service lines. On the right, it shows the prediction accuracy. On the bottom, you see sort of 10 columns. Each one of them represent a probability. Well, that is the model's direct output. So our model will say, this particular address, 123 Main Street, has 0 to 10 probability of being lead. That is the model saying it's non-lead. It's likely, right? Non-lead. So when we approached FDEP and talked about these performance criteria, what we advised FDEP and what they seem to also have required in the guidance is this. For classifying a line as non-lead, if we're looking at the left side, the very left column, this column needs to achieve a 90% accuracy. And that is what we do, and that's what we aim to do for every predict modeling project. Once we achieve that, then we can call all of those predictions non-lead and remove them from the unknown pool. But keep in mind, there are other probabilities there, and if they're in the middle, if something is in the 50% probability of lead, that is simply the model saying, I don't know. Katie will touch more on that in the next few slides. But that is the concept of accuracy.
Thanks, Doug. And when we measure the performance of predictive models, we need to look at more than just the overall accuracy. We need to go even farther than just breaking down that accuracy into more granular assessments, like Ja just showed. This is where the concept of false negatives and false positives come into play. So these terms come from something called a confusion matrix. You can see an example here on the screen. So a false negative is when the model predicts non-lead, but the actual material is lead or galvanized requiring replacement. And a false positive is the opposite. The model predicts lead or GRR, but the actual material is not lead or GRR. So both of these are not great, but from a public health perspective, false negatives are obviously worse. And so when we create models, we can calibrate them to minimize these errors. But there is usually a trade-off between the two.
Yeah, Katie, when you said it's confusion matrix, I just always thought it's truly confusing, but that's not why it's named.
Indeed, it's not.
Okay,
There's a whole technical explanation for it. Yeah.
Right. I think to link it back, Katie, FDEP's guidance requires utilities to avoid bias and minimize false negatives and false positives. Essentially, what they're saying is just to minimize wrong predictions.
True. And then we covered the concept of representative data. That's a way to try to ensure that your model isn't biased in its training data set.
That's right. Yeah. So we covered some of those FDEP requirements. Katie, another question we hear a lot is, what if we have no lead or GRR?
Yeah, so the short answer is you can still use these methods. So I have on the screen an overview of the predictive modeling process. And so to to answer this question, we sort of need to go through both scenarios, right? Of having lead or GRR and then, not having lead or GRR. So let's start at the beginning. We start with a recommended representative verification set. And then, those verifications get completed in the field. And if we find lead or GRR in those verifications, we would configure a machine learning model using your field verified data. And this model would predict the probability that remaining unknowns in the system are either lead or GRR. And then if we go back to the fork, if no lead or GRR is found during field verifications, we can use a statistical method to characterize that uncertainty around all the rest of the unknowns. So we'd say we have 95% confidence level that what we observed in the sample is generalizable to the rest of the unknowns. So in other words, we don't expect any lead or GRR. We can also take a little more conservative approach and estimate kind of the upper limit of lead or GRR that we could expect to find in the unknowns, given that we didn't find any in a representative sample. So that estimation is dependent on the number of field verifications performed, the number of unknowns that remain, and it can be reduced by increasing the sample size, in this case, which would be performing more field verifications. There's also another step that can be taken in this scenario of not finding any lead or galvanized requiring replacement. And that is a type of machine learning called one-class classification. So in this case, we only have one class to model with, and it's non-lead. But we can treat it, the problem kind of becomes more of an anomaly detection type of problem, or rare event detection. And what we're trying to do is predict locations that don't really look like that train and test set for the machine learning model. So those are the ones that we'd want to go out and double check to make sure that they're not lead.
Yeah, Katie, the one class classification, it's kind of just saying which one of those doesn't look like the rest.
Exactly. Right? Yeah. Yep.
And I will add that this is the best available tool we have for handling any utility situation where no lead or galvanized required replacement is found. One important distinction, though, Katie, and I want to mention this. GRR or galvanized as require replacement. A utility can only call a galvanized line, not a GRR, if there's evidence to show that it was never ever downstream of lead. That is the only way we can call it not GRR. Otherwise, it is GRR, which is treated like lead, unfortunately.
True. It's always a good reminder, to kind of talk about.
Absolutely. What about two-class classification?
Yeah, so two-class classification is when we have, two classes, right? So we found some lead and GRR, and then some non-lead, non-GRR. We can train the model to distinguish between the two. So that's kind of the mainstream case and application of predictive modeling in this context.
Yeah. Great.
Yeah. So another question we get a lot is how many field verified data points are required for predictive modeling? So to answer this question, we consider 3 steps in the process. The first is that initial representative sample. We want enough in that data set to achieve, as Daw said, a 95% confidence level, so that that proportion of materials that we observed in the verification set is generalizable to the unknowns. So for a utility with 30,000 unknowns, for example, the initial amount is going to be roughly between 380 and 590. And there's no proprietary way to calculate that. It's just a standard statistical formula. If you Google sample size calculator, put in the number of unknowns that you have in your system and 95% confidence level, you'll get the same numbers. And then that second step here is that we actually use the data to build an initial model. to target more field verifications. That's, a classification model. And we want enough data in our test set at this point, where we're measuring the accuracy of the model to achieve a 95% confidence level in the model's reported performance metrics, which are calculated on that test set. So for that same example of utility with 30,000 unknowns, for the second kind of step, we'd want about 1,500 to 3,000 field verifications performed. And these are not additive, by the way. We're going from 380 to 1,500 and then down to the next step. So we're not adding these up. And then at this point, we'd be using the model's predictions to guide additional targeted field verifications. And we usually see the model's performance improve with more field data. So it's impossible to estimate exactly how much more field data will be needed from here. But to help utilities with longer term planning, we usually advise our customers to plan on field verifying anywhere from 10 to 20% or more of their unknowns, depending what the goals of the program are. In some cases, it could be less. In some cases, it could be more of it. Folks are looking for long-term planning estimates. That's a good rule of thumb. So, for example, in this system with 30,000 unknowns, that would be roughly 3,000 to 6,000 or more. Really important to note that there will probably still be some services that you can't strongly classify as either lead or non-lead based on the model's predictions at this point. So those will remain unknown. So I can explain this concept a little more in the next slide. So basically, you have a model that predicts the individual probability that a service line is lead or galvanized requiring replacement. You can see that on the left-hand side, the predictions are mapped. The color of the dot is associated with the probability that that site is lead or galvanized requiring replacement. And then when you aggregate the predictions in 10% increments, you can see kind of the profile or distribution of lead probability for the water system. So that's on the right-hand side. And so those predictions near 0 and 100% are typically more reliable. So those are the ones you'd want to label as a definitive material in the inventory based on the model's predictions. And then that middle yellow area generally stays as unknown. And as you iterate through the process of some continued field verifications and then rerunning with that data, we typically see those yellow bars reduce and the blue and or red bars increase. And this is just one example. These thresholds are not set in stone. This is an example of what worked for one water system based on their program goals and the accuracy of the various predictions in their model.
In other words, Katie, I think what utilities can take away from this slide is it's an iterative, maybe multi-year process, right? Ongoing until we are done. It's not going to be one shot, all done, and then nothing else in a 1 year process, unless you dig very aggressively.
Correct. Yes, but to provide an optimistic note, you can classify some of the unknowns as non-lead based on the model's prediction.
Right.
And so that's super helpful.
Yeah.
And
absolutely.
lead as well.
Yeah, and at the end, it still can. I mean, a utility can still look at a significant reduction of field work comparing to digging them all.
That's the goal.
Yes.
That's the goal. Yep.
Another question we get a lot is, well, that sounds great, but how much does it cost? The true answer is it depends, but I really don't like giving that answer. So if we look at a really large utility in Florida, the predictive modeling for 2 years cost less than $250,000. While that could look like a lot, in comparison, however, I just did a little calculation. On Amazon, a breeder filter is about $20. So that's about 10,000 breeder filters. I think for anybody who has that large utility, the price is based on has about 90-some thousand unknowns. So for somebody having that many unknowns in the next 10 years, sending out thousands, tens of thousands of filter is entirely possible. With modeling, you can reduce that significantly. And the second item is I also calculated how much that money would get you, how many field verifications it'll get you. It's about 250 field verifications. Field work is expensive, right? The contractors in Florida are charging about $500 per hole. And if you do 2 per address, that's about 250 field verifications you can do. I think it's needless to say, predictive modeling gets you a lot more unknowns tackled than just 250. Then there's also the cost of doing notification to the unknowns annually, the cost of handling the PR piece, and just the labor to do all that I cannot even calculate. I think predictive modeling done well will give you really satisfying results and save you a lot of money in the end. Katie, can you talk to us about the timeline?
Yeah, we get asked a lot. What's the timeline like for predictive modeling? So typically, we receive the utility's existing service line data, and there's some level of compilation and formatting and question and answer that takes place to make sure we're understanding the data correctly. So we have some time here to account for some back and forth between Trinnex and the customer at the very beginning of the process, depending on the level of support that they need, getting the data kind of ready. Once we have the data in the desired structure and format, which by the way is basically if you have your data organized in the way that the EPA and FDEP has indicated a service line inventory should be structured, that's basically what we're looking for. So once we have that desired format, we can recommend field verifications to establish that initial representative set. That really only takes like a week. So in total, though, this first step of getting your data and then recommending field verifications can take about 4 to 8 weeks. And then, so the time it takes for those recommended verifications to be performed can obviously vary depending on things like the physical verification methods and the number of crews you have in the field. And we usually see it takes about 4 to 16 weeks because we're getting closer and closer to October 2024. The faster that we can get those initial field verifications done, the better. And from there, it takes 3 to 6 weeks for the initial model configuration. And then for each model run, the time frame is about 1 to 2 weeks. And so we like to allow in some time for, like I said, initial model configuration and then review of model results on each rerun, because this is not a one-size-fits-all modeling problem. So although we've done this many times and have kind of like a standard, set of code that handles these data sets, different utilities need different configurations to make sure that they get the right results.
Thank you, Katie.
So, yeah.
So with all that covered, I'm sure many of you are just thinking that how do I decide whether I do predictive modeling or not? Like, what's the thinking process? So I would like to take you through this. I have talked to several utilities using this kind of thought process. So think about a utility that has 10,000 unknowns, and this also works for any utility that has more than 10,000 unknowns. You basically have 3 options left. Do nothing now, do predictive modeling, or start field verifying all unknowns. I will first say that predictive modeling does not apply to everybody, certainly not. I certainly want you to know, however, who it applies to and why it might apply to you. So let's look at the first option, do nothing now. Well, do nothing now means you got to do everything in the future. So that means you're submitting 10,000 unknowns if you have them in October 2024. That means then you are on the hook for annual notifications and disturbance requirements, so long these 10,000 unknowns are in your inventory. And they don't change until year after year. They don't change until you reduce them. And I'm sure that the utility who chooses to do that would have to start digging in the next few years. Well, you cannot, but if you cannot completely reduce the unknowns in 2027, likely LCRI's mandate will kick in that you're required to replace 10%. And that includes the 10% of the unknown. So that's 1,000 every year that you have to commit to replacing if you want to be compliant. And here's I call it the twilight zone of LCRR, LCRI that nobody knows the answer to. I asked FDEP, what if a utility has 10,000 unknowns, they have to replace 10% in 2027, but they indeed have no lead? Because exposing a copper line and putting the dirt back in does not count as replacement. You have to actually replace it. Well, as much as that is sort of a nonsensical question, it actually is a practical one that I think many utilities and regions are submitting to so not FDEP, to EPA for clarification by, I think, the 5th, which was this Monday. But that is a real question. That is a compliance risk. But just moving on, then the cost of future is high because you actually have to dig everything in the future. Certainly high PR risk because of notifications. And one more point that actually most people don't think about, I would like to point out, is it actually also really is a high risk for public health. So if you have any lead or galvanized in the ground, especially lead, and you don't know where they are, so certainly then you will not pinpoint them and replace them right away. With a model telling us where the lead lines are, we can replace them right before we dig anything else. So it helps with public risk as well. So do nothing doesn't look like a great option. So second is do predictive modeling. Well, if we do predictive modeling, a few things. First thing is there's upfront cost, right? The cost of doing the model and also a commitment to doing field work along the way. That is probably front loaded. The benefit is, however, you certainly lower significantly your future cost, not by millions. It could be by tens of millions. You certainly significantly can reduce your annual notifications along the way, your disturbance requirements, because we're tackling these unknowns, calling them known instead of unknown, and hopefully known non-lead. And we also can significantly reduce the impact of the replacement requirement, the 10% requirement coming in 2027. And by doing so, we're lowering the PR risk as well. Fewer notifications and fewer disturbance requirements means fewer filters and probably angry customers. And then the lastly, but not the least, certainly, if the model can predict where the lead and galvanized are, we can hit them fast and replace them, and therefore protect public health. Option number 3, verifying all unknowns. And Katie will talk about later when this might be a good method. You are on hook for certainly notifications and disturbance requirements because the fieldwork cannot possibly reduce unknowns fast enough unless you're committed to a lot of work upfront. So all the same disadvantages of doing nothing applies. It just simply gets you started earlier. But one thing I think is a huge risk factor is really the PR, right? So we are going to have to send notifications out, and not to say you have to find a lot of money. I mean, for 10,000, you're looking at $10 million in the next few years to hire a contractor to do them all. I think when predictive modeling is present, this option becomes less attractive. So just to put it all together, if we evaluate the cost, the utilities work, health risk, and PR risk in these 3 options, I think we can easily conclude that, yes, predictive modeling is front-loaded in the cost, but it certainly is the lowest cost overall when LCRI is completed. The work required is medium for now, but low in the future, right? Because we do some work now, but we can reduce the field work in the future. And the lowest also in health and PR risk. Katie?
Yeah, so if you're trying to understand whether it'll be valuable for your water system to do machine learning, it's what type of the predictive modeling that we talked about. Something to consider is the number of unknowns that you have. So we have some general guidelines here. If you have less than 3,000 unknowns, machine learning might not be extremely helpful. Depending on your field verification options, you could potentially physically verify all of those properties and not even worry about machine learning. And there are some LCRI implications to using this as a technique that, are manageable for a larger number of unknowns. May not make sense for the smaller bucket of unknowns. So it might be beneficial to just remove any uncertainty. If you have between 3,000 and 5,000 unknowns, it's kind of like a middle area. Machine learning may still not be helpful. You just really need to scrutinize the cost benefit of analysis and look at like verification options available to you and compare that to predictive modeling costs. And then, associated like that middle yellow zone, right, of properties that aren't going to be able to be classified as one material or another right away with predictive modeling. If you have more than 5,000 unknowns, that's where we start to be more confident in saying that, yes, machine learning will be helpful and valuable in helping you reduce those unknowns in a cost-effective manner and target your field work towards probable lead or galvanized requiring replacement services. It's also important to note there are always exceptions. These are just general guidelines to think about. And also really important to note the table here in the bottom, the statistical method where that 95% confidence level comes in and that statistically representative initial sample between 300 and 400 sites to estimate the composition of materials in the rest of your system. That's always a good place to start, no matter how many unknowns you have.
Yeah, thank you, Katie. And one more thing I'd like to add is, the statistical method only applies if you do not have any lead or galvanized in your system. Galvanized require replacement. The moment you have GRR or lead, it does not work at all anymore. Then the only predictive modeling method you can use is machine learning.
Sure. And it's useful, like you went through the steps of collecting that representative sample. You found lead or GRR. It's useful to know kind of what you're working with, but then to your point, you need to go on to machine learning to figure out the probability that individual services are lead. You can't stop with statistical analysis in that case.
Right. And statistical analysis, really, Katie, is just a step in the entire machine learning process.
Correct. Yeah.
Yeah.
Yes, that's definitely okay. So we've covered a lot today. I want to make sure to leave you with some additional resources. So we have some hopefully helpful articles on the Trinnex blog. And you can use the QR codes there at the bottom to visit the Trinnex blog. And then, we have experts, on the team who have decades of experience and like PhD credentials weighing in on this stuff. So it's really helpful to read some of those perspectives. So scan that QR code, that has some helpful information, hopefully for you. And then you can also scan the QR code on the right-hand side to learn more about Lightgas Predict. And then obviously, as Jay said in the beginning, I would love to hear from any of you and answer your questions. And then also recently I published an article in Journal AWWA with some folks that I work with from CDM Smith on predictive modeling in service line inventory development. And it has a lot of just helpful information to kind of wrap your mind around it for regulators and utilities alike. So I encourage you to check that out if you haven't already seen it. I'll
Thank you,
turn it back
Katie.
to you, Doug, to close us out. Yeah.
Yeah, and we thought we saw your interest in predictive modeling and thought, wow, this is truly a great opportunity to further actually help you to answer the question, if I want to do an RFP, how should I issue an RFP? Because I think most of us, we know how to issue an RFP for pump stations, but predictive modeling is new. So Travis and I will cover that in the next webinar. You can scan this QR code now to sign up if you want. And obviously, the fastest way to get it, if you want, is to directly purchase it. But if you have to go through RFP, this is going to be very helpful to you. So with that said, we conclude the presentation and we have the time to answer some questions. So let's see. First question, Katie, how do you achieve 95% confidence level?
Yeah, so 95% confidence level requires two criteria: a large enough sample size and a representative sample. And so the sample size required for a 95% confidence level can be calculated and you can pull up like a statistical sample size calculator and put in your number of unknowns, the confidence level that you want, and then it'll give you a number as to if you are using a 5% margin of error, which is generally accepted by other states providing guidance and the EPA's own guidance. Then you will get between 300 and 400 verifications. So that's a 95% confidence level in the fact that the proportion of materials you observed in that sample size of 300 to 400 is generalizable to the rest of the unknowns.
Thank you, Katie. Another
Sure.
question is, do site verifications clear out unknowns and give an accurate information, or just duplicating the scope and timely accomplishment using predictive modeling? I can answer that question. The site verifications actually is what the kind of data we put into the model in order for the model to predict. It's not a replacement of modeling, but certainly clears out some unknowns along the way while providing the data for the model to be able to make predictions. So they kind of work hand in hand together, and it's an iterative process. Do some verifications, do some model runs to reduce the unknowns in a significantly faster fashion. It's a good question. Another one, Katie. Oh, is the model actual software or just factoids to follow?
The model is actual software. It is not a one size fits all for every data set. It's actual software that we configure and sort of set appropriately for each data set.
Yeah, and I will add that, Katie, we didn't even touch the other functions of the software platform at all today. So the software that Katie's referring to is called LEDcast, and some of you already know this. It's a software tool. It's like this. LEDcast is the iPhone, and machine learning is the FaceTime. Everybody wants FaceTime, therefore they buy iPhone. But then there are so many other things on the iPhone. On LEDcast, we can talk about it another time in detail. It handles the inventory. It handles the field data collection, customer interface. It also takes care of, it could help with the sampling requirements and replacement if utilities go that way. So for any interested, you can follow up with me to learn more, but it is actually a software tool. Okay. Katie, another question here. What capabilities are provided for compliance reporting?
Yep, so we have a out-of-the-box report that details the predictive modeling process, including the data that goes into it, how that data was leveraged inside the model, what the important features in the model are, all of the necessary performance metrics, the confidence level, the distribution of predictions in the system, the accuracy of those predictions in 10% increments. So like everything that we've, had so many discussions with state regulators, and then we're practitioners ourselves. So everything that we've collected in conversations with them, and then that we know from our experience, goes into that report. And some states have specific questions that, may require additional, like, write-ups, right? And so we handle that with like just some consulting hours, like in the package, with the predictive modeling.
Yeah, I think ultimately, Katie, it's important to know that we also will stand behind the utility and help defend the approach with FDEP. Even, we know them, they know us, and it probably won't be very difficult, but still, we will be we can defend it for you, so you don't have to tell the story yourself. Next question, Katie, here. Okay, so will Letcast request specific addresses to be checked, or will it simply ask, go and field verify this number of lines in this area?
Great question. Specific properties. Because the algorithm and the sampling approach that we use, stratified random sampling, is going to recommend specific sites for a reason, because they will make up that defensible sample. We know that in reality, like, you can't get to exactly every, let's say it's 350 to start with. You probably won't be able to get to some of them because maybe they're not accessible. You can't get permission for, if you need to get into private property, things happen. So we provide a backup list as well with instructions for how to select from the backup list in a way that does not compromise the statistical quality of the resulting sample.
Thank you, Katie. Another question, for a utility company what are the data you need to prepare if you are intending to venture into predictive modeling?
Definitely. So, yeah, absolutely. So the good news is all of the information that you have or need to use to compile the initial service line inventory is information that the predictive model will also make use of too. So like, structure year built, service line installation dates, diameters, if you have any water main information, plumbing codes, just anything that you're researching to build your inventory could also be useful for the predictive model. We then add demographic data to add, that additional element to it.
Thank you, Katie. Let's see. Oh, that's another good question. Does this predictive modeling include owner sides of the service line? And I shall add private side as well.
Yes. So we will model for whichever side is unknown. We just need to have samples or verifications to feed and train the model for that side. So if you have utility side unknowns, we're going to recommend utility side verifications to model that side. And if you have private side unknowns, we're going to recommend private side verifications to model that side. And ideally, we can recommend them in a way that most of them are at the same site, right? So then when you're at the site, you just verify both sides and we use that information to model the rest. Depending on the degree of overlap of unknowns between both of those pools, like the private and utility side, there might be some instances where we just say, go out and field verify, one side. And if you know the other side from records, by the way, it's good practice while you're there to check that side too. Some states are starting to have guidance around, validating the reliability of records. And this is one way to do it. And these guidelines are kind of evolving. So it's just something we're telling every state is a best practice to do.
Yeah. Yes, absolutely, Katie. And just along those lines, there are other questions about still whether the verification is by area or randomly. It is randomly done, and while also trying to ensure that we don't ignore any specific groups of addresses. But I would say if you have questions in that regard and you want to start the field work early to prepare for predictive modeling, feel free to reach out to us afterwards. Like Katie said, there are other states guidance I can share with you to get you started, right? Start doing the field work first. So we can do that and help you out. Okay, let's see. Katie, by the way, we have 2 minutes left. We'll try to answer as many as possible, but if your question is not answered, we will follow up with you afterwards to make sure you get what you need. So maybe one of the last questions here. Can you explain how the one-class modeling works? Have you been able to achieve 90% accuracy using that method to find outliers?
Yeah, so one class classification is like a rare event modeling. So totally different than two class, right, where we have lead and non-lead. And it's like Doc kind of explained earlier, which of these does not look like the others. So it's looking for characteristics of the unknowns that a machine learning model would, classify as different enough from the known materials to merit additional investigation. And so when we have done anomaly and rare event detection modeling in the past, we have achieved good success and high accuracy. The interesting thing about the application of anomaly detection models in this case is that if a model predicts, let's say like 100 properties out there in the unknown are actually lead, and those are the ones you want to go investigate, you actually want that model to be incorrect 100% of the time, because you want those to be non-lead. So it's just that additional layer of due diligence, right? Of like, we have a statistical basis for claiming, no lead in the system, or, at maximum percentage, but we also are going to provide like due diligence to go out and check to make sure, that rare events don't exist in certain cases.
Thank you, Katie. I know we hit 11 o'clock. Unfortunately, we can't extend any longer, but for the questions that are not answered, we certainly will follow up with you. Thank you very much for your time attending this. I appreciate it.
Thank you.